Okay, welcome to Unit 5, Lesson A. We are talking about angles and how angles operate, okay? So, we're first of all going to talk about parallel lines and things that happen with parallel lines. So, there's a specific relationship between them and angles that form with them and angles when they intersect with them. So first of all, we have to remember one of our key concepts is the sum of the measures of the interior angles of any triangle adds up to 180. Okay, so that's one of the principles we have to remember. So a triangle adds to 180, and also the exteriors of the triangle will add to 180. Okay, and we also find that any straight line will add to 180. So a straight line that is broken up into a number of different angles, A, B, and C. If we take A plus B plus C, we're going to get 180 degrees of straight line. Okay? So we do deal with straight line angles quite often. Okay? So those are our first couple concepts that we need to understand. So if I were to put the number right here that said 40 degrees, and I wanted that exterior angle, I would first recognize that that makes a straight line together. So you're going to take 180 and we're going to subtract 40 degrees, and that's going to give us 140 degrees, and that's right there. Okay? So that's one of our angles there. Now, the other way we can find an angle is what if we have the outside part? We can easily find the inside. So let's say I've got this angle right here. Perhaps they tell me that it's, let's say it's 94 degrees, just for giggles. If I say that guy's 94 degrees, I want to find out how big that angle is. Well, what do we know about those two angles? What should they add up to together? 180, right? Because they add a straight line right here. So I take 180 minus, and I'm going to get 86 degrees. Now I can find the other two angles in my triangle. So what I mean by that is I can take a look now, and this triangle right here should add to 180 on the inside. So I'm going to take 180 and minus 86 degrees and minus 40 degrees. Okay? And that's going to give me the angle measure right here. So how big is my angle there? Any ideas? Let your fingers do the walking on your calculators. Yes, it is going to be 54 degrees. Good job. Now, again, working backwards, I can find the angle that it's attached to create this straight line right here. So I can take angle A to B to E. Now, when we name angles with one letter or three letters. It's more accurate to name them with three letters so that we know the corner points that it's introducing. So what we do is we find out the angle we need. That's the letter in the middle. The other two letters go on the outsides. So for example, this angle here could be named angle EBA because this is an A right there. Or I could have angle ABE as long as the B is in the middle. Okay, the other two letters are on the other sides. Okay, so how do I find that angle? What are we going to do to find this missing angle B? Well, what do we know about 54 in that angle? They create a straight line, which adds up to 180. So then we're going to take 180, and we're going to minus the 54. So if we minus 54, how big are we going to get? 126. Good. Now, you see that we also could just add the other two angles in our triangle. Those two angles there would add to 126. Okay? All right. We talk about interior angles and exterior angles. So interior, obviously, are going to be the ones inside, and the exterior one is going to be the guy outside. My board is off again. Okay. We'll try to use the board. There. Whew. We're in luck. Okay, so we were talking about interior versus exterior angles. So the interiors are the guys on the inside, obviously, okay? And the exterior are outside. Okay, we need to know some definitions. So we're going to draw some objects and we're going to write some definitions. So, who remembers what a scalene triangle is? What is a scalene triangle? Any ideas? That's right. All three sides are different. Okay, so we can just draw a triangle, 3, 4, 5. All sides are different lengths. Okay, so all the sides are different lengths. That's the key. How about isosceles? So what do we write for isosceles? That's right. So two angles will be the same, meaning and the sides will be as well. So it matches with sides and angles. So we're just going to draw a little scaling triangle. If I put two notches like that, those mean they're identical. So two sides are identical. And two angles are identical. Okay, so it has two sides and two angles that are identical. Okay, that's for sure. Now, how do I know which angles are identical? It's always the ones on the bottom. Okay, so it's the ones that are attached to the lines, okay, that are identical. They're attached to the lines that are identical. So far we've got a triangle with no same sides, two same sides. What's equilateral? All three same sides. Good. So we could have 5, 5, 5. All sides and angles. Okay, so all sides and angles are identical. Okay, so all sides and angles are identical. How about a right angle triangle? Absolutely. It's a triangle with a 90-degree angle in it. And we always show 90 degrees with a little box. Okay? So that is a 90-degree triangle. Now, can we have a 90-degree triangle that is an equilateral triangle? Never. Okay? You'll never get an equilateral triangle that will have a right angle. Because remember, if it's an equilateral triangle, that means all sides and all angles are the same. If I've got one angle that's 90, that means I can't have two other angles that add to 90 because then I'm too big. You can only add to 180, okay? So that means that you'll never have a right triangle where all sides are the same length because we know the hypotenuse has to be longer. It's the biggest side, okay? So you'll either get a scalene triangle where they're all different, or we can get an isosceles triangle where the two short sides can be the same, okay? So they can be isosceles or scalene. Okay, they'll never be equilateral. So you'll have one 90-degree angle automatically, and the other two angles add to 90. Okay, and that's how those work. An acute triangle. Yes?
Is there where all the angles are below 90 degrees?
Perfect, well said. So all angles are less than 90 degrees. Well said. So all angles are less than 90 degrees. I'm going to raise it up for you so you can see better from the back there. Let me know if I've moved it up too far. Are we okay there? Okay, make sure you're writing this stuff down, guys. Obtuse triangle. Any ideas of what that is? Good. So one angle is between 90 and 180. Okay, so you're going to have one big angle and then smaller angles. So you've got one big one, and then the two in the corner are tiny acute angles. Okay, so your one angle is between 90 and 180. Okay, you can't go over 180 because if it does, it's no longer a triangle, it's a straight line. Okay. All right, I'll give you a minute to write that down, and then we're going to go to the top of the next column. Okay, quadrilateral. This just means any shape with 4 sides. So a quadrilateral itself means all 4 sides are different. You could also have a quadrilateral where they're all the same because a square qualifies for that. 4 sides. You could also have where 2 sides are the same, left and right, and 2 sides are the same, top and bottom. That'd be a rectangle. You could also do it with a parallelogram and a rhombus. These are all quadrilaterals in our list here, okay? Every single one of them. Now, trapezoid, there's different kinds of trapezoids. So one can look like this, basically like a door stop, kind of like a shoe, okay? And other trapezoids can kind of look like this, where they've got angles on both sides, and they can be different, okay? So one of them could have a 90, and one may not, okay? Now the key about these is that the top is way smaller than the bottom, okay? And that's usually always the way it is. It has to be that way to be a trapezoid, okay? Now we're going to go through area formulas and all that kind of stuff for each of these. We don't need to know a lot about them, except for the way their lines work and how many sides they have. So we're going to start putting them on diagrams. All right, so trapezoid, 4 sides again. Usually all 4 sides are way different, okay? You'll either get 1 slanted side or 2 slanted sides, okay? So they look like a shoe or a doorstop, something like that. An anvil, something like that. All right, parallelogram. Well, it's basically a rectangle that's been kicked over. So 2 sides are identical, okay, and the other 2 sides are identical, okay? And the beauty about a parallelogram is that opposite angles are identical. So the 2 blue that I drew in circles are identical. The 2 I'm going to draw in green are also identical, okay? So you have 2 acute ones and 2 obtuse ones, and they will be identical. One thing we also know about a parallelogram is that these, every corner, when you add 2 corners together, they will always add to 180. Okay, so 2 corners equal 180 degrees. Doesn't matter which 2 corners you add, as long as the corners are connected by a line. So that means the blue and the green here are connected by a line. So that means this one and this one are connected by a line. So that means blue and green would add to 180. Okay? Same way going all the way around your parallelogram. Okay? They will always add to 180 as long as they're touching. Okay? So touching the same line. If they're across from each other, they're identical. Okay? They don't add to 180 if they're across from each other. They're identical. All right. Rhombus. A rhombus is a square that's been kicked over. So a rhombus has all sides of the same. A lot of people call it a kite. So it's a square that has been kicked over. So it looks like a parallelogram, but all sides are the same. Okay? That's what these little ticks mean. All sides are the same. Okay? Take those ticks off because they are not the same. All right. So because of that, it's got the same properties as a parallelogram in terms of the interior angles. So that means across from each other are going to match. They'll be identical. And that also means across from each other the other way will be identical. Okay? And then, same property, if you take 2 corners and add them together, they're going to add to 180. Okay? That's the way it works. Rectangle, 4 90-degree angles, 2 pairs of sides of the same length. So I've got 2 long sides the same length, and I've got 2 short sides the same length. Okay? So you've got 4 90-degree angles no matter what. Okay? 4 90-degree angles. So you're going to notice that a rectangle or any quadrilateral will add to the identical amount as a circle. So what does a circle add to interior? 360. And so does any quadrilateral. Specifically because if we take rectangles and squares to begin with, what we've done to find these other objects is we've manipulated and changed the rectangles and squares. We've changed what they look like, which means it changes the size of their angles. So that means the 90s no longer become 90s, they become slanted. Okay? So that's what's happening with those. So a square, same idea. 4 angles are 90 degrees. Only this is the same as like a rhombus in terms of every side is the same length. Okay, so all 4 sides are the same. And the diagram itself, mine shouldn't be slanted, I just can't draw it very well. I suppose I could grab a square here and draw a beautiful square. There's a beautiful square, guys. Ooh, 2 of those. Look at this go. There we go. We got some beautiful squares. Okay. You ready to rock? All right, let's take a look at the next one. So now we're going to do some matching. So I'm going to give you a couple minutes. I want you to match the name of the object to the object. Okay? Now, what we're going to do is we're going to number the objects. So all you've got to do is write the number beside the letter up here. Make sense? Or you could write the letter by the object, whatever it is. But we're going to number the objects so that you know what you're doing. We're going left to right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11 objects. Push pause now and play when you're ready. Okay, I'm going to give you a couple minutes to write down the definitions. We've got 2 parallel lines that never meet. We've got perpendicular lines that meet at a 90-degree angle, and we've got lines that add up to 180 degrees. Push pause now and play when you're ready. By the way, here's the matching example, just in case. Check your work. Moving on. All right. Now we're back to a couple more definitions. So 2 intersecting lines, they form a pair of equal opposite angles. So basically what this is saying is anything that forms an X is going to have 4 angles. 2 will be identical one way, 2 will be identical the other way. So that means these 2 will always be identical, top and bottom, and left and right will always be identical. Okay? Now you could have an X any which way. You could draw an X specifically that way, or you could have an X that's more slanted, kind of, I don't know, I'm drawing X's that all still look like X's. I guess it could look like a T, and it would be the same idea. So this guy would match this one, this star would match this star, okay? So opposite means across. So anything across will be identical, and that's going to be an important information for when we're identifying features of parallel lines. With a transversal coming along. So now we're going to talk about what if objects are similar. So if the measures of corresponding angles are equal, that means they were grown or shrunk by the same factor, scale factor. So that means if I've got an object down here, we're going to take a look at this object. And if I were to do the side ratios, I want to find out how much that object grew by. Well, this is your old object. And this is your new object, if you remember from grade 9. So we have scale factor is equal to new over old. And we are going to just find out what the scale factor is. Now, we need to check every side, because if you only check one side, you don't know if all sides match. What I mean by matching is the ratio you get from dividing these numbers needs to be identical. And if it is, that means that those 2 objects match and they are scale factors of each other. So we do the dividing. We're just going to take the first side here. So we're going to take the shortest side on both of them. So the scale factor of the short side is going to be 5 over 2.5. So how big is 5 divided by 2.5? 2?
It's 2.
Perfect. So the first blue line there, it grew by a scale factor of 2 times, so it multiplied by 2. We're going to take a look and see what happens to the line on the bottom, the longest line. So we want the scale factor for the longest line. Here we did the shortest line, now we're doing the longest line. So on the new object, the long line is 8.4. On the small one, it is 4.2. If we divide them, do we get the same scale factor? Yes, we do. So far, the 2 sides work. We need to make sure all 3 work. So now we need the scale factor for the medium length side. So we're going to take 8 over 4, and yes, that has a scale factor of 2. So all three sides grew by the same scale factor, which means all of them are a scale factor of the original old object. Okay? So they are a scale factor of each other. Okay, we've got a couple practice ones. So let's take a look, everybody. By knowing one angle, we can find the other three. The first one is the opposite feature. The opposite feature means across an x will always be the same angle. The other rule we're going to refer to is the 180 rule. Anything that adds to a straight line or to a triangle. In this case, we're talking about lines. So anything that adds to 180 is going to form a straight line. So that means I can find this angle by going 180 degrees minus 137 degrees. That's going to give me my little red dot. That's going to give me that angle in there, that smaller angle. So how big is our smaller angle? 43 degrees. Beautiful. Now, remember, opposite angles will be identical, so that means the other angle across from him is also going to be 43 degrees. They match. Okay? All right. I'm going to put one down here for you, and I want you guys to find the other the other three angles. Find those other three angles. We're missing some angles there. All right, Tread, what's the answer over here? Tread, what's the answer? Oh, 97. Beautiful. Okay, whoa. So we see here in the diagram, anything adds up to 180. So our beautiful little friend at the back tells us we have 97 degrees. So 97 degrees. Now we know our two angles, so we can find the ones across from them. So that means Z will be 83 and X will be 97 degrees. Okay, you're just finding the guys across. They will always match. All right, let's take a look at the next few. Which of them are congruent? Congruent is another word that we have a definition for, which means exactly the same. So they're identical in every way. So if we want something identical in every way, it's got to be the same shape and the same size. That means the side lengths are identical and the angles are identical. So which ones of these could be matching pairs? We want to find matching pairs that are identical. Any ideas?
JKL,
JKL and ABC, you betcha. Any others? Good. The red ones are also a pair. What about the guy on the right? He's his own family. He has no friends, yeah? He's the guy that doesn't have a matching pair. So this guy, no matching pair. The other two had a matching pair. Okay, this concludes lesson 1A of Unit 5, Trigonometry and Angles.